Hello everyone, this is a project movie review sentimental analysis system for movie website. We are Yifandu and Tianhan. Last semester, in course Big Data Analytics, our group built an online movie recommendation system based on our own movie website, Columbia Movie. And this recommendation system aims to increase the website sales by accurately predicting users' tastes. This time, our goal is to improve users' experience while browsing our website. So, we add the critics' reviews into the web page and label them with positive or negative mark. And finally, rate the movies according to the labels produced from sentimental analysis. In this case, the users won't bother to read every review very carefully to select a decent one to watch. As for the dataset and the tools, the training dataset we used for sentimental analysis to fit the model is called Large Movie Review Dataset, version 1.0. It includes 50,000 reviews along with their associated sentimental labels, and the movie IDs are from IMDb. The labels are balanced with 25,000 positive reviews and 25,000 negative reviews. And we have the movie review dataset for our website database, which is a Rotten Tomatoes movie reviews dataset. We created this dataset by ourselves. It includes 15,000 unlabeled reviews from critics for 2,000 different movies belonging to our website database. I will specify how do we create this dataset in next slide. And we also use Python interface natural language toolkit to implement several text processing libraries and several text classifiers. Our system is built on Spark. The motivation we built the movie dataset with reviews by ourselves is that our original website database is based on movie length dataset, which only contains the basic movie information without users' reviews. And there's no such a database include both movie information with the associated movie reviews existed on the internet. So what we did is to use Rotten Tomatoes API to gather movie reviews from critics, and use Python to write a function that looks up the first 20 top critic Rotten Tomatoes reviews for a movie, and finally insert the reviews into original dataset to get one whole CSV document. Then I will show you the CSV document. As you can see, this is a newly produced dataset we created, and the quote column refers to the reviews we fetched from the Rotten Tomato API. As for the algorithm, we partition it into 5 parts, which are tokenization, pre-processing, feature extraction, classification, and evaluation. We have tried several ways to pre-process the data and try to find the best informative features. We also utilized different classification algorithms to compare their testing accuracy in order to find the best one to use. Then another teammate will continue to introduce the algorithm part.
Here in tokenization, we segment the sentences into single words, including punctuations, and we use a simple bag of words model where every word is a feature name and it associates with the value of true. In preprocessing, we remove punctuations and stop words because they are less informative than other words, and including them would just increase the size of the index without improving precision. And we use different methods in feature extraction. First, we use single word detection, and we use bigrams detection, which means we include two adjacent words as a bigram as a feature. The reason that we use bigrams is that, look at this sentence, for example. It has two negative sentences, which including not interesting and never recommend. If we use single word detection, it would detect interesting and recommend and may classify this review as a positive review, which is incorrect. But if we use bigrams, it will detect the not interesting bigram and never recommend bigram, and most likely to classify this review as a negative review, which is correct. And we use two classification methods. One is naive Bayes classifier. Basically, it finds the most probable label for a review, and it uses Bayes theorem. In naive Bayes classifier, it computes the conditional probability of a feature given its class label. And we also use linear support vector machine classifier, which find the best split of the dataset that would maximize the margin. And these two groups are classified by their labels. And we also use decision tree classifier, in which we find the feature that if we split the dataset by this feature, we can get the maximum information gain. After we train the model using the above methods, we can evaluate the test result with accuracy, which is the percentage of correctly predicted labels among all labels, and positive precision. For example, here there are two data points that their original labels are positive, but just one predicted as positive label, so the positive precision is half. And there are just two positive predicted labels with just one that its original label is positive, so the positive recall is also half. Negative precision and recall is similar to positive precision and recall. And we can show you some results derived from the demonstration. First, we can try classify reviews without pre-processing. And here is the code. We run it using Spark. It may take some time. And here is the result. We can see that in the most informative features, there are a lot of bigrams that including punctuations and some stop words. They are not bigrams actually, so we need to do pre-processing to avoid such phenomena. And we can also evaluate performances of different classifiers and feature extraction methods. And here is the code. We can run it in Spark. Okay, here is the result. Well, we can see compare different classifiers. We can see that the decision tree had the worst performance of just 60% accuracy, precision, and recall. It is probably because decision tree classifier are likely to be overfitted. Also, it takes a long time for decision tree classifier. Naive Bayes classifier and support vector machine classifier has similar performances, but SVM behaves slightly better than naive Bayes. And as for feature extraction method, when we compare single word features and bigram word features, we can see that using bigram improves performance slightly comparing with single word features, and we can add more complex feature extraction method to improve the performance, like tagging and semantic reasoning, and so on. Next, we can compare most informative features of single word and bigrams. Here we can see the most informative features in single word, and the bigrams has some similar results like avoid, ball, and all. And there is an interesting phenomenon in bigram feature extraction method that the most informative features are mostly negative. That's probably because most people post reviews to complain about bad movies. And then after we evaluated our classification method and feature extraction method, we can choose the best classification methods such as SVM and naive Bayes, and using bigram feature extraction method to use the trained model to predict labels for our new reviews and store them into our dataset. We can run the code to see if it can successfully and correctly predict some labels. And here is the code, and we can so run it in Spark. Here we write two new rows in our dataset as naive Bayes predicted labels and SVM predicted labels. You can see that here we write such two columns, and it may take some time. Okay, here are the results. We can go to see the dataset. Here we can see there are the labels predicted using naive Bayes classifier and the support vector machine associated with each review. We can see that the results of knife bias and SVM are very similar. They just have slight difference, but they are both accurate enough for correctly classify most of the reviews. So we successfully classified our movie review according to their subjectivity. Thank you.